Yesterday's assignment with the unit circle may have been difficult, and I apologize. I think I should have done a little more legwork to help you prepare for it, and I apologize my video was so long last time. I tried to be a little more succinct. So, my goal today is to show you that as long as you know this table, you can answer any question that comes to the unit circle, and I'll show you how. Okay? So the first thing I want to note is patterns, because the unit circle is full of patterns. And here's one you may or may not have known. I'm going to say that 0 is the same as square root of 0 divided by 2, and that 1 is the same as the square root of 4 divided by 2. Just trust me on this one, all right? So if you think about when you have 0 radians, 0 radians corresponds to the point 1, comma 0, right? Because cosine produces an x value, sine produces the y value. So I could write this as square root of 0 divided by 2, and I could write this as square root of 4 divided by 2. All right. When I talk about pi over 6, pi over 6 corresponds to the point radical 3 divided by 2 and 1/2, which happens to be the same as square root of 1 over 2. Okay? When we talk about pi over 4, well, pi over 4 is radical 2 over 2, comma radical 2 over 2. Okay? When I talk about pi over 3, that corresponds to the point 1/2, which is also the same as square root of 1 over 2, and radical 3 over 2, right? X comma y. And then when I get to pi over 2, I am on the y-axis. And that produces the point 0, comma 1. Did it backwards. Which is same as square root of 0 over 2, which is same as square root of 4 over 2. So I would recommend you pause the video right now and look at what's happening to the number underneath the radical sign in the numerator as the angle increases. What happens to the numerator of your sine values? As the angle increases, what happens to the numerator in the cosine values? That should help you remember some things, in case you don't know it off the top of your head yet. Okay, so I'm going to keep this in mind because as long as I know my x and y's, I'm good to go. Here's some more background information you should know. Last video, we were talking about sine, cosine, tangent, cotangent, secant, and cosecant. So, if I have sine of an angle is equal to 1 over cosecant of an angle, aka the reciprocal. I could also say that cosecant of theta is equal to 1 over sine, aka the reciprocal of sine. If I have cosine of theta would have to equal 1 over secant of theta. And if you want to see why that's true, go back to the previous video or even just Google it. Look at the definitions of cosine. Look at the definitions of sine as like a trig ratio. And that'll help explain why I can say these statements in terms of the how they're reciprocals of each other. All right, last but not least, we got our tangent. tangent of theta is equal to 1 over cotangent of theta. So we could also say that cotangent of theta is equal to the reciprocal of tangent. All right. And the reason I mentioned this is that I was asking you for some of this information yesterday. So we had to make sure that you know what how they're related to each other, because if we also do a little bit of substitutions, right? Remember, I also said that sine is y and cosine is x. So that means that for cosecant, it would be equal to 1 over x. I'm sorry, 1 over y. If I'm talking about cotangent, I'm sorry, dang it, secant, because they're blue, that would be 1 over x. And yesterday, I also stated that tangent can also be considered as sine divided by cosine. So in this instance, that would have to be equal to y divided by x. If I think about the coordinate points. And since cotangent is the reciprocal of tangent, well, cotangent could be considered x divided by y. Right? So if you need to, jot these down in your notes, use this as a reference, right? These are the basic breakdowns. I've even color-coded them for you to help you with it. Okay. So that's it for this video. In the next video, I'll pick up with this information and show you how to kind of put it all together.